Okay, now I'm gonna work through the second part of the practice exam. All right. So we'll start off with number one here. Let's get this. There we go. This is looking at fractional reserve banking. This is where banks keep a fraction of the deposits and use the rest of it to make either loans or some type of investment with it. All right, so in this problem, we're looking at First Bank's balance sheet. This is an example of double entry bookkeeping. All right, so there's two. Every time you make a change, it's going to affect both sides: assets, liabilities, and capital. All right, so both sides have to equal each other when you're doing double entry bookkeeping. So here we have reserves, and we're also going to have loans and investments. On the other side, deposits and also capital. No capital in this one, but in the next one we'll have some. All right, so what happens here? Well, the households deposit $50,000. The bank's gonna hold 25% in reserve. All right, so you just take 50,000, multiply it by 25%. That's gonna give you 12,500. Okay. And to use a remainder, you just subtract that from 50,000, and you'll have 37,500. So you add these together, it's 50,000, and deposits 50,000. So both sides are equal to each other. All right. Now, did the money supply increase? Yeah, this is what fractional reserve banking does. Like, it allows banks to create money. All right. How much did it increase? So what's the new money supply? Well, that's deposits plus any loans or any investments it's made. So deposits is 50,000. Then it creates money when it loans out this remaining bit right here. So the new money supply is 87,500. So it increased by 37,500. Okay. Now C, it asks, would the money supply increase if it was 100% reserve bank? No, it's not going to increase because they're just holding on to the reserves for you. The money's just changing form. The money's changing from physical cash from the deposit, where it's just demand deposits now that are in use. But the bank's holding on to all of it, so that's all the money there is would be 50,000 here. So the bank would hold all 50,000 as reserves, and the money supply would just change composition from physical to demand deposits, but there would be no money creation with 100% reserve bank. Okay, so that's it for one. And let's go to the next one. So erase this. Here we're looking at bank fragility. And this is a big issue for fractional reserve banking, is making sure people don't get scared and worried about being able to get their money. Like, it causes a panic in a bank run. All right, so we illustrate how this can go bad. First, we need to fill in our sheet here. Deposits is going to be 47,000. What about capital? Well, it's going to be 3,000. The bank has 3,000 of its own money. No, what about reserves? Let's go have 25% of 47,000 here. And so if you take that, and if you take 47,000, multiply it by 0.25, you'll get 11,750. Right. What about loans and investment? Well, that's the remaining bit of it, so that's going to be 38,250. Okay. It's assets, liability, and capital. All right. Okay. Now I want to know what happens if the loans they've made or it loses 7.5% of its value. How much capital does the bank have left? So remember, capital is just assets minus liabilities. So what are the assets? Well, the assets, it's only going to be 0.925 of these loans and investments now because it lost 7.5%. So you can take that and multiply it by 38,250. Also, in its assets, it has its reserves. It's not losing anything to them because it's not making any types of investment or loans with it. Minus the liabilities. Liabilities here is the deposits. Remember, it's not the capital, that's banks. So we're trying to, determine how much capital it has. That's 47,000. Okay, so let's figure this. Let's see if there's any capital left or if it's negative. So 0.925 times 38,250. That'll be 35,381.25 plus 11,750 minus 47,000. All right, you add those together, and then you subtract 47,000. You should get 131.25. So the bank still has some capital left. So if everybody showed it to get their deposits, they have enough value to actually do this. But what happens though, that's what we'll look at for B. What happens if people they hear about these bad investments and it causes a panic? Well, and it starts a bank run. That means everybody rushes to get their bank. So now the bank's got to call these loans and divest in their investments, and it may not get back to full value. So we're going to say it loses another 5%. Okay. So now this 35,381 is going to lose 5% of its value. So you got to multiply that by 0.95, and that'll give you 33,612 and 19. All right. And to see what the total assets are, we need to add it back in our reserves. This will give us a total of 45,362.19. So if we subtract 47,000 from that, well, it's going to be negative. All right. Capital is going to be negative 1,637.81. I also know, well, if it has the central bank needs to bail it out, like how much liquidity would need to provide to cover its liabilities? Well, the central bank needs to inject, $1,637.81 liquidity into the bank. All right. Okay. It could do that, and it could cover all its losses, and the bank will probably have to go bankrupt or something afterwards, but at least it could cover the customer. That's the big thing. They want to make sure people don't lose their money. All right. And that's why the central bank backs up these banks. And that's why there's federal deposit insurance. That's to ensure that these panics don't happen. All right, you want people to be sure their money's safe at these banks. All right. Okay, so that's it for 2. Now we'll go. How did this happen? Weird. All right. Now we'll go to number 3. All right. Number 3 is looking at money supply. All right. So it's given marginal revenue for 2 countries. The marginal revenue for both of them is 350 minus 7Q. Country A has a marginal cost of 8Q minus 40. Now, what it wants us to do, what will be the equilibrium amount quantity of money in this environment if it's competitively issued? So we just set marginal cost equal to marginal revenue, 8Q minus 40 equals 350 minus 7Q. So we add 7Q to both sides, we'll get 15Q. Add 40 to both sides, we'll get 350 plus 40 over here, 390. So the equilibrium quantity of money for A here is going to be 390 divided by 15. That's going to be 26. Okay. So what about part B? Now we're looking at a country that has marginal cost of 6, so it's always 6. So we'll set this marginal revenue equal to 6. Okay, so it's just going to be 7Q equals 344. And so the equilibrium quantity for B is going to be 344 divided by 7. So that's 49.14. So a good bit more. Even though it has the same marginal revenue, there's going to be the money supply is going to be much larger. Okay, so C, it wants us to graph both of these out. So we'll do that next. Let's erase this. All right. C. So here we have our marginal revenue, marginal cost on the y-axis. X-axis is the supply of money. We'll do this for both of these. Okay. Well, the country A has increase in marginal cost. Okay. And this little point here, you just set its marginal cost equal to 0. So 8Q minus 40 is 0. I'll give you 5. So right here is 5. And from that point on, it's going to increase. All right. Marginal revenue will come down. It's going to intersect at 50. All right. It's like you get that by just setting the marginal revenue equal to 0. 350 minus 7Q. That'll give you 50. Q equals 50. At that point on, it'll be the max of the other thing, so it's always going to be 0. I won't keep going down. It's always going to be 0. Okay. All right. Let's just draw the equilibrium. Just right here. Here for country A, it's 26. Now we'll go over and look at the other one. And it's going to be, its marginal cost is different. It's always the same. It's always going to be 6. So it's just a flat line like this, horizontal line. Marginal revenue the same way, comes down. Here's 6 at 50. What was this equilibrium quantity? Well, it was 49.14. Okay. On D, indicate which country to be using Japanese yen and which country to be using cowrie shells. Well, the yen would be over here. Constant marginal cost. That is like, when it's producing its money, it's constant cost. Like there's no scarcity. It doesn't really have to worry about, most of the time it's just they're just entering in numbers to the computer to add money into the reserves of banks. So these costs are very low, they're not going to increase. Whereas the cowrie shells over here, those aren't used anymore. They used to be used a long time ago in certain countries or certain societies. Now there's a limited amount of them. Okay. And if you're going to have to keep going, maybe you have to go like in deeper part of the ocean. You can't just collect them on the beach. So it's going to become more and more difficult. You got to go out to islands to get them and stuff like that. So the costs are going to keep increasing, going to get more difficult to find and to increase the money supply. Because it's increasing, you have a lower equilibrium quantity. Okay. Now, which country should have a monopoly issuer and why? Well, that should be Japan here. They should have a monopoly issuer. Maybe they can keep it here at 25. All right. And the reason a monopoly is going to do this, they want marginal revenue greater than marginal cost. All right, they'll think ahead. They keep this higher. That means the next period when they produce money, it'll be worth more. And since they're monopoly, they can actually control the price. All right, they don't have to worry about a coordination issue. Like if you have competitive issues, they can't really coordinate unless they form like a cartel to do something like this. All right. So this makes sure you can calculate what the marginal revenue is here. The marginal cost is 6. Marginal revenue, what's it? Well, you just set your marginal revenue equation equal to 25. All right. And so that's 350 minus 7Q. All right, so it's going to be 325 equals 7Q. So you divide 325 by 7. And what you get, let's see, I didn't calculate that. Where's my calculator at? Here we are. Okay, so you just take 325 divided by 7. That's going to be 46. Your marginal revenue here is going to be 46.4. Okay. So you can see the marginal revenue is greater than marginal cost. And the reason the monopoly should do this, because now, like for the next period, the profits are going to be really big. All right. This will slow down inflation, keep the value of the money higher, and be better off in the long run. Now, with central banks, they'll actually like keep this in a range, like say from 20 to 30. All right. This is active management. And they do this target inflation, usually. Like a 2%. 2% rate is what we usually get. Ours is a little bit higher now, or a good bit higher. But even now, they wouldn't target, ideally, it probably wouldn't be 1 or 2%, it'd be a little bit higher because of some issues on the supply side. Like 3 or 4. If they had it where they wanted to, it'd probably like 3.5%, 4%. All right, but they're going to, adjust depending on demand for money, the amount of money in the economy. Okay. All right. So I think, is that it on that part? Yeah, that's it. So now we'll go to question 4. Erase this. All right. So 4, Bitcoin production. So we're going to assume instead of cowrie shells, this is country A is using Bitcoin. All right. So we can go ahead and draw it. There's intersection was at 50. Comes up at 5. And the intersection where the equilibrium is at, quantity is 26. All right, so what's happened here? Well, electricity costs have skyrocketed. So marginal cost is now 8Q minus 20. Okay, so now we need to find the new equilibrium quantity. Just set marginal cost to marginal revenue. So it's 8Q minus 20 equals 350 minus 7Q. So that'll be 15Q equals 370. So that's going to be 24.67. Right, so this is our new equilibrium quantity, 24.6. So it's going to be less. All right, it's just the electricity cost is skyrocketed. That means the marginal cost is increased. All right, it's become more costly. That means this is going to shift back. All right. Okay. And as a result of that, you're going to have a decreased equilibrium quantity because it's more costly now. So the miners here are going to produce less as a result of it. They need a higher revenue to be able to cover their marginal costs. And as a result, there's less created. Okay. Now what it wants to show, we illustrated the shift. All right. You can put this too. This is 5, and this is, if you calculate that, it's going to be 2.5. Okay. All right. Now, last part. The Bitcoin algorithm will adjust in 2 weeks or less after this change in marginal cost. We'll need to lower or raise marginal cost to keep Bitcoin in its long-term growth path. Run a potential marginal cost equation after it adjusts. Well, due to this increase in marginal cost of electricity, miners aren't producing as many as they were before. So now it's falling behind its long-run trend. Okay, so the algorithm will see this, see that it's produced less tokens. They'll see its computational power, and so it'll need to lower. It needs to lower marginal cost. All right. And so you can just put, so the new equation could just be back where it was to begin with. AQ was it minus 40? Yeah. But as long as it could be anything. It could be AQ minus 30. As long as you decrease it, move it back. It just needs to. It needs to move forward back towards the original equilibrium level. It may not go back to exactly where it's at. Whenever it does calculate, but it's going to be close to that. Okay. Just needs to move back towards the equilibrium. So vice versa, if like marginal costs were lower for some reason, it could be any reason, the algorithm will see that and it'll raise marginal cost. So it'll need to like do the opposite. It would need to increase the marginal cost, just shift the curve back. All right. Okay, so that's it on 4. 5. Let's see. Let's erase this. Monoalphabetic substitution. Okay. So there's a 2-letter shift being used to create the following cipher message: GVJ, GT, GWO. All right, so the first one, G, you need to go back 2 letters. All right, if you go back, it's E, F, G. So it's going to be E. All right, the next one, V, same thing. Go back 2 letters. All right. U and T. If you keep doing this pattern over and over with everything, it should spell Ethereum. Okay. So when you decrypt, you're changing ciphertext, something you can't read, and something you can read. Now, part B here, you just want us to encrypt BitGold. And what do we use? A 2-letter shift to encrypt it here. So B will go to CD, I will go to JK, T will go to V, G, HI, O, PQ, L, MN, D, EF. All right. And you can't read it. That doesn't make any sense. Yeah. Okay. Remember, when you're encrypting, you're turning into something that you can't read, ciphertext. When you're decrypting, when you decrypt it, you should be able to read it, understand what it says. Now let's go to 6. All right. This is polyalphabetic substitution. Here, you need to use the Vigenère square. Part A, it's once you encipher a word, that is, change something from plain text to ciphertext. And once you use the code word blue egret, Cuyahoga. Okay, so this is your code word. The plain text is blue egret. You want to encrypt it in form of ciphertext. So that is something you can't read. All right, so what do you have to do? You have to look at your plain text. So you'll go to B, the top row in your Venn square, you'll go to B. What word do you use? You got 25 choices for ciphertext here. Well, it's where you use your code word. So you go down till or C, that is the second spot here. And then you go across to the middle till they both intersect. So they intersect at D. Just keep doing this over again. Now you go to L, go out to L on the top, and then you will look for the next code word, U. You'll drop down till row 20 or use that. And then so you just go down and you'll get F. Okay. You just keep doing this process over and over again. You get D, F, T, E, L, U, X, E. Then you have to start over because you've used all that. And you have to use C again. Right. And when you do that, you'll get V. So this is your ciphertext. Now you want to decipher a message. Now I spelled this wrong. I just left it what it was though. Here you do things opposite. All right. Using the code word Homer to decipher the following message. So Homer is a code word. Ciphertext is PZXEU. Now you need to get the plain text. All right. So here you gotta use your code word first. Look at that H. So you go down to H. This is row 7. Then I want you you go over till you hit P, the ciphertext. And then you look straight up, and that's what letter you're replacing with. It'll be I. Right. Same thing with O. You go down to O, row 14, and then you'll go over until you hit Z. And then you go straight up from there, and it'll be the letter L. Now, if you keep doing this process over and over again, you'll get Iliad. It was supposed to be Iliad. I misspelled it. Right. Homer wrote the Iliad. So I misspelled that, but that's what you'll get, Iliad. Okay. So now we'll go to our last one, number 7. Okay, so this is a digital signature. Okay, so part A, we'll get the first part of the digital signature, and we'll use this algorithm. The X coordinate of P, and then do a mod N. Let's see. So the X coordinate of P is 9 and 11. So this is a coordinate on an elliptic curve. And we use the first part of it, 9, the X coordinate. And then mod, the N value that we're given is 8. So you just take 9 divided by 8. That gives you 1 1/8. And since we're doing Mandela, we want to take this remainder here, 1. All right. So R equals 1. What about B? This was a little more tricky. It's not too bad if you. I won't give a real difficult one here. It'll be small, something you can see real easy, not like your own homework problem. All right. So the inverse of I we're given here is 11. I saw it. I used the wrong thing here. Is this right? Let's see. I'm using the wrong stuff here. Man, how did I get this wrong? Sorry about that. Yeah. All right. Let's work through this again. Okay. So R is equal to that 9 is right. Medela 13. Okay. Because the N is 13. I don't know where I got. No, N is 8. That's right. I did that right. Okay. So that part was right. Sorry. So it is 1. R is equal to 1. This is next part I messed up. Yeah, I put I is equal to 3 for some reason. But it's 11. Make sure. Yeah. So it's 11 inverse. T, the message that we're going to use, we'll put it next, and that was 9. Plus, we got to use R now, and that was 1. Times the private key, that was 13. And we take the mod of 8. And the first part here, we got to get this first part. And that is, we got to rewrite this 11 inverse mod 8. All right, remember to get this, is whatever 11x mod 8 is equal to 1. This may take a few runs. Let's see. Let's try 11 times 3. That'll give us 33. 33 divided by 8. 4, 4 and 1 8. So that's it. Yeah. Okay. So x here will be 3. And so we'll substitute that for this. So now this becomes 3. 9 plus 1 times 13. So that's 22 mod 8. So it's 66 mod 8. And if you divide that, it's going to be 8 times 8 is 64. You have 2 left. All right, so that's the remainder. It'll be 2. So your digital signature here is your RS is going to be 1 and 2. Okay. All right, so that's everything. Yeah, on this, make sure you can do, I mean, it's going to be very similar to this, just it'll be different numbers. All right. So you make sure you know how to do every one of these things I did on this part. All right. Okay, so that's it for that.